right, thank you all for being here in this remote area. This is going to be a talk about building a native application in Java. We all know that Java is really good at building an application for multiple platforms. They say build once, test everywhere. And with native, it is build once, test everywhere, and fix everywhere, because, well, reasons to be about to see in a minute. All right, SDKMAN. Who here uses SDKMAN? Okay. Who here is running on Windows? Nobody. So usually you see a distribution of people that are using Windows that don't use SDKMAN, and the other people, well, they can use it. And that's because SDKMAN is by origin a tool written in Bash, which really works well on Bash operating systems like Linux or OS X, for example. You can run it in the Bash Git for Windows. However, there are some quirks there to make it work, but you can run it there. So, for example, you can install Java, find a version of GraalVM that you want, and install that version of Graal. SDKMAN is not necessarily for Java only, so you can also install Maven, for example, like in this case 388, and then everything is up and running. All right, I work for a company called Tennet. Tennet is the high voltage grid operator in the Netherlands and a part of Germany. So being a grid operator, it's not necessarily a IT company per se. We have around 10,000 employees working for Tennet. However, there are only a few hundred developers working there, because most of the people are working in the fields, building those power lines and doing actual manual work. That means that we are a small number of people within that company. My department, System and Markets, which is actually responsible for maintaining the grid at 50 Hertz, because we have the grid at 50 Hertz in the Netherlands, and like the rest of Europe, and sending out invoices. And we do that with around 85 Java developers. So that's not much. So we are a small group. That small group is just an annoyance for the people that maintain working laptops, for example, for the people that are running in the field. Because they usually want to run Windows, like they want to run Office, they want to run Outlook and that kind of stuff. So they standardized upon Windows. So guess what we got? Windows laptops. Luckily, there are beefed up versions with a lot of RAM in them, and well, it's workable. We're a local admin, so it can work. However, I do like SDKMAN, and when I started, we were still in a transition of running Java 8 and migrating it to Java 11. So an SDKMAN there was really useful. So what I've decided to do is build the SDKMAN in Java and make it Windows first. So everything should run up in Windows. So it's actually on GitHub. You can go to the releases page and download the latest versions. Today there's a 3.1 release. It can install itself, and then it's ready to be used. Well, of course, you can also install a SDK, a Java SDK, for example, and will actually set up the Java home and path variables for you. So this all works within Windows. Of course, you can use it and install, for example, a Maven version. Of course, Maven also needs some environment variables like Maven home and the path variables. And you can install another version if you need to. Now, when all that is done, unfortunately, it is still Windows, so we need to log in again into our system, because the path variables are not updated automatically. It's a Windows thing. So when we log in again, we can actually start up a command prompt and actually see, for example, that the Java home is set and the Maven home is set and the path variables is set correctly. So then we can start up a command prompt and run Maven here, for example. Well, we installed 2 versions of Maven, so let's switch the Maven version that we use to 3.8. When we close SDKMAN, you can see that it is now using 3.8.8. So this is really nice. This works from the command line in Windows. and also on Linux or OS X, because I have implemented the same thing that the SDKMAN actually does with bash scripts. It's actually heavily reliant on SDKMAN on operating systems that have bash installed. So it leverages that, but you have at least a UI which you can click around. So let's go back to the beginning, all the way back to when it all started. So this is my journey of creating the SDKMAN from scratch. So let's first start off with a hello world. Let's go back to the basics. So we're going to create a new Maven application. I use Maven because I know how it works, and well, it's quite easy. So let's create a main class with a hello world in it. Great. If we run it, we get a print hello world. Yay. However, now we want to have this hello world application shipped to our customers or our intended users. So we need to package our application and ship it to the users. So what can we do? Well, the first option is just to create a fat jar, bundle all the dependencies, and ship it to the users. This is very easy for the developer. There's no additional tools needed. You can configure Maven for this and well, be done. However, this is not very user-friendly because they need to have the specific GRE setup that you or higher, then you have to build your application. So if I build my application with JDK 24, the user needs to have at least JDK 24 or higher. So that requires a lot of user setup. A lot is, well, usually a little bit too much for the average user. So what can we do then? We have, for example, JPackage. And JPackage is actually shipped with JDK 14. And it is an addition onto the fat jar. So first you can create your fat jar. And then you can call the JPackage application and tell it where the jar is and what type of image you want. For Linux, you can create a DMG, for example, and then you get an application that you can drag and drop in your application thing in OS X. This also works on Windows and Linux, and there are multiple ways of packaging your application. And like I said, it is quite easy and comes with JDK 14. However, it depends on the operating system for the experience that you got. In Windows, you can create an executable, but on OS X, you create an application that you need to drag and drop in the application folder. It's a bit hit and miss. And it still bundles the entire Java or GRE that you need to run your application. So it's quite a big file to give the users. Then another option is JDeploy. And JDeploy is actually a IntelliJ plugin that you can use. You can also use some node modules to build your application. And when you've done that, you will get a nice download page on your GitHub, where the users can download every system, every operating system that they want your application. And when they download it, they will be presented a nice installer. And this installer will also ensure that shortcuts to the quick start or the desktop are created. And there is also a way to automatically update your application if there is a newer version of it. So that's really quite nice. So it supports GitHub releases. It has the auto updater, and for Apple applications, it is required to sign your applications. If you don't do that for Apple, you get an annoying pop-up saying that this application is untrusted, and well, you have to go into the security settings and explicitly say that this application is allowed to run on your system. So it's quite annoying, and JPackage helps with that. So they will sign the package with their key. So your application will become a JReleaser application. It's not really fancy, but at least you get rid of that annoying security pop-up. However, you can, of course, always sign your own application. However, that requires an Apple account, developer account, and that costs you $100 a year, I think. So that's expensive for hobby project. And it lacks command line support. So my application is a command line thing, so I really want to have command line support, so that's not going to work. Another option is JBang, and JBang can be installed with a single bash or PowerShell command. It's quite nice. And once you have installed that, you can just run, for example, JBang JReleaser at JReleaser, and it will fetch the metadata from a catalog. We'll download every dependency that is required to run your application and set everything up for the user, and then it can be run. So it handles the environment. It can be used for graphical interface applications or command line applications. However, it's not really an app. People need to download explicitly the JBang thing and then run it. So the fourth option, and the option that I've chosen, is use GraalVM. GraalVM is great for command line applications and GUI applications. There's no Java required for the user. It has a native app experience, so because it is a native app. And the speed is a lot faster. If I run my fat jar, it takes around 2 seconds to start up the SDKMAN UI in total. Doing that natively, it's usually around 480 milliseconds, so that's a lot faster. If you're a developer, you just want to switch something, waiting 2 seconds for a UI to pop up, it's cumbersome. So this is a big plus here. However, it doesn't have an installer process, so we have to create that ourselves. And like you've seen, I've created that, and it's quite complex. So let's see how complex that is. So first off, we're going to make our Hello World a native application. Luckily, there's a really nice tutorial on the GraalVM website, which in detail explains what you need to do to make everything work. So the next few slides is just copy-pasting from that website. So if you need to, you can always refer to this guide. So first off, we're going to change our POM, and we're going to create a main class in there, because we're going to define that main class a lot of times. So let's make a property of it. And we're going to copy-paste the native profile from the website from before, and just the native Maven plugin. And this is a profile native, so it will only run if you explicitly say you want to make it a native application. It will automatically run in the package phase. So let's do that. Let's call Maven package bnative. And if we run this, you will see that first it will compile the application, and then it will perform some analysis, build everything into native code, and try to figure out every path that the application is going to take, so it won't build the entire JDK to native. It will only build up the parts that you're actually going to need. So if you have a Hello World application, it's quite small application. So once this is done, we can execute in our target folder the JavaFX application, and it runs Hello World. Great. Well, switching back to Windows, because we are Windows first. Luckily, there is also a nice website on the GraalVM website, or a tutorial on how to set up this on Windows. Unfortunately, you do need Visual Studio to make this work, because you're going to need some build tools, you need C++ and a lot of things. So once you have all things set up, you will have a new command prompt. That is the Visual Studio developer command prompt. This has all the tools set up and paths set up correctly. So this is the only command prompt we're going to be able to build our application in. If we're going to use the normal command prompt, it will just fail to find the C++ compiler and that kind of stuff. So we can just call the Maven package bnative again. When we run this, it will run the exact same thing like before. Unfortunately, this is going to take a little bit longer time, because this is in a virtual machine, and this is not really that fast of a virtual machine. But now we have a executable in our target folder, and if we run that, we do have our Hello World application. So quite easy. So if you have an application that doesn't have any reflection or complex logic, this is the way to build a native application. Great. Now let's do reflection. reflection is used a lot in JavaFX. So before we go to JavaFX, let's first figure out how reflection works with GraalVM. So what we're going to do, we're going to extend our application a little bit. We're going to create a greeter interface. We're going to have two implementations of that greeter interface, a native greeter and a world greeter. The world greeter will just return hello world, and the native greeter will return innovation thrives in the native layer. So we're going to use reflection to load up the specific greeter. So we're going to take in the arguments from our application and concat that to the greeter class and instantiate that class and then call the greeting on it. So if we're going to run this application and don't provide any arguments, it'll actually crash because can't find a null greeter. So we're going to tell the application to start up with world, and if we run this, we get the hello world. Great. So if you're going to build this application again with GraalVM, just the package pnative, and well, that compiles just fine. However, if we try to start the application with the world arguments, like we just did in IntelliJ, it will now fail because it cannot find the class world greeter. And that's because it was loaded via reflection, and GraalVM doesn't know that the thing was loaded via reflection. So we have to tell that. So we can create a reflect.json configuration file. And in that configuration file, we can actually say we have two classes with some methods that you're gonna use, and that those two classes will be bundled in the application itself. So this is quite nice. However, this is manual work. I have to create those files myself, so I really don't like manual work. So let's figure out a new way to do that. Luckily, there is an agent that can run alongside our application. So if we start up our application and interact with the application, it will create those configuration files for us. So we're going to change the configuration of the POM a little bit. So we're going to introduce the execmaven plugin, and we're going to say that it's going to just start out our main class and take in our program argument. Then we're going to add the extensions to true on the GraalVM plugin, and we're going to enable the agents in the configuration. So if you want to run this, we need to add a lot more flags to it. We need to say the agent because we want to enable the agent, and we're going to call the exec plugin to start our application, and we're going to give it our program arguments native. So if we run this, we got a reflect.json in our target folder. Okay, that's not really where I want that stuff, but I really would want that stuff in my Git repository. So we need to tell the GraalVM agent to move that to a different location. But at least it created our reflect.json. In this case, only for the native class, because that's the only thing that we started with. However, if I start my application again with the world argument, you guessed it, it replaces everything. So this is annoying. Luckily, we can fix this. We need to do two things. First off, I really don't like the target folder, so I'm going to change the config location to our main meta-inf location, so it can be checked into Git. And well, not everyone needs to run this every time. And we're going to say that the location of the agent is a merge dir, so it will merge the new agent results with the old ones. So if we do this, everything is moved into our main meta-inf native image folder, and if we run it twice, we got two different entries. So it nicely got merged. So this is what we're going to use. So if we compile to native again, we can actually call our application with world and the native arguments, and both just work. Great. And this will always work, this will also work on Windows and OS X. It's no problem. So let's move on to JavaFX. In JavaFX, it's quite easy to create a UI, and it's even more easy if you can just drag and drop stuff in the UI. So Gluon has adopted the scene builder from the JavaFX project, and they maintain it, and they release the new versions of it. So if we download it, we can start it up, and we're going to just create a new empty application. And here you can see everything that we can drag and drop on top of it. So let's create a simple greeter application. So let's create a anchor pane. This is where all the buttons and stuff will go. So we can change, for example, the width and height of the anchor pane. And that will also influence the size of our application. So it's quite a small application now. So let's find a button to add a greeter. We can just change the text of that button to greet me. And we want to have the JavaFX call a action greet me click when that button is clicked. Where do we do that? We need to add some controller for this class. And that controller is a Java class, which we're going to create right now. So it doesn't automatically create that controller class. So we need to do that manually. So we have our main controller with the greetme click. And as you can see, the main.fmxml is stored also in the resource folder. So we can actually load it later on. So let's do something with JavaFX. We need to add a bunch of dependencies. We need to add a base, we need to add graphics, we need to add controls, and we need fxml. Fxml is optional. If you really want to, you can also define your complete UI within code, just like Spring, for example. So that last one is optional, but I really like the drag and drop stuff and really can see what I'm doing. So we're going to add upon our controller a little bit. So the greetme click, if the user clicks the button, it will show up a alert, a dialog with the greetings from that greeter. And that greeter we're just going to set with a setter. We're going to instantiate this controller class in our main later on. So if we're going to create this controller, we're going to call start. And start will take in a primary stage, and the primary stage comes from JavaFX. So that is a thing that we're going to get a little bit later. And we're going to just say we want to load that main.fmxml as a resource. We pass it to the fxml loader, and we're going to say load that the thing and add it to the scene, and we're going to show it. So unfortunately, JavaFX is module-based. Who here uses modules? Ooh, one. That's cool. At least one. So usually none of the people actually use modules themselves. Modules are usually for libraries and that kind of stuff. But in this case, we need to define a module ourselves. So we're going to create a module, and we're going to require the same modules as we have defined in our POM. And we need to open up our package to the JavaFXML and graphics modules, because those two packages will do a lot of reflection in our application, so they need to have access. Then we're going to change our main to a JavaFX application. So we're no longer going to have the main arguments here, but we have a start, which it takes in a stage. That's the primary stage that JavaFXML is starting up. So that's the stage that we're going to pass on to the start method of the main controller. We still load up our greeter like before, and we set the greeter to the controller so that the controller can actually use that greeter. So if we run this application, we get a small application with a button. And if you click on that button, you get the world again. So that's great. Now let's make this a native JavaFX application. So let's call the same method that we just did before. And let Maven figure this out. And we run into a snag here. Unfortunately, GraalVM doesn't have the JavaFX bundle of the JavaFX modules baked into it. So Maven will start to complain that a module is not found, even though we have defined that module or dependency in our POM. JavaFX is a special kind of thing. It needs to be inside of the JDK. So the default GraalVM doesn't have that, and there are some ways around that. So we need GraalVM plus JavaFX. Well, there are currently, as far as I know, 2 solutions for this. You can use the GluonFX JDK, or you can use the Liberica, I probably butchered that name, NIK, the native image kit. It's a JDK with JavaFX built in and everything that's required. Unfortunately, I was not able to make an application run on multiple operating systems coherent. So it's really promising, and I really hope they ironed out the stuff a little bit later, but unfortunately I'm stuck with Gluon. They're lagging a little bit behind. If you check out the SDKMAN listing for Gluon, the latest version is from JDK 17. So it's a bit behind. As you can see, I just did that. So we're going to install the latest 22 JavaFX version with JavaFX with JDK 17. Luckily, there isn't really a feature in 18 to 24 right now that I really need in order to build my application. So as this is a hobby application with a build in my spare time, this is fine. So I'm going to install it, and I'm going to use that in this shell. But now we can also clean up our POM a little bit. We're going to remove the X plugin and replace it by the Open JavaFX plugin, because that will handle launching the JavaFX application for us. And that is actually being used by the Gluon plugin. So the Gluon plugin will actually handle all the GraalVM stuff for us. So this is quite a small configuration. And then our arguments for Maven also change a little bit. If you wanted just to run our application, we can just call GluonFX semicolon run. And if we do that, we get our application. And of course, it still works. But like before, we wanted to run our agents because we want to gather all the reflection data. So GluonFX also has a run agents argument. So let's use that and click through our application, and it will actually create all the files for us. And luckily, it defaults to the main resources native image folder. That's quite nice. So no longer in the target folder. But as you can see, there's a lot of stuff being created. A lot of JNI stuff, and there are also a lot of reflections being done. This is great. Otherwise, we also needed to do that manually. But now everything is generated. Unfortunately, we do need to fix up our main application. So we have to add a main to our main application, even though it's already on the application itself. Don't know why it needs it, but it definitely needs it. Otherwise, it will break the build. And we're just going to call launch, and well, that's about it. So then we can call the Maven compile GluonFX build. And once that's done, we have a nice application in our target folder. It's a little bit on the bottom. But it will write it down into the target, GluonFX, and then your architecture of your CPU. And well, there we will place the executable. And when we run this, we get a nice application. And actually, we can also do this on Windows. We get the same results, except we get a executable out of it. We can do this on OS X, and it will work just fine. So let's make it a little bit more complex, shall we? Let's download a file from HTTPS. Let's do something with a remote service. In this case, I'm just going to download the README from my SDKMAN website, just using standard stream inputs, and that's about it. So if we run our agent again, we get a lot of things like ComSun, crypto provider, and that kind of stuff. That's logical because we are doing HTTPS, so that's a secure connection. So that needs to be in there. Sounds feasible. However, if we run this agent again on OS X, we get stuff like the Apple security Apple provider. That's not going to work on Windows or on Linux. Okay, this is an example, but GraalVM doesn't know where this class is, and it will blow up. So, unfortunately. We can work around this. Unfortunately, we need to create a native image folder in our resources for every distribution, for Linux, for OS X, and for Windows. So what we're going to do is create some profiles in the POM, and we're going to create a profile for Mac, for Windows, and Linux, and we're going to activate it based on the operating system that you're running on. So if you're running on OS X, you will get the OS X profile automatically, so it will use the native image folder for the OS X and so on. This is a property. Unfortunately, we can't pass this property to the GraalVM plugin because there's a bug there. It hasn't been solved yet, so we need to do some workarounds. So what we're just going to do is use the resource plugin, copy it from the location that we defined in our property, and just copy it to the native image folder. That means if you run the agent, it will just output into the native image folder, and you have to manually copy it into the correct folder yourself. But then the next time you run it, it will automatically pick it up as it should. And this way you can actually create a native application cross-platform. However, that means that you have to run the agent on every operating system. So if you forget something, it will break your application on that thing that you forgot it on. So what I've actually done is create a unit test that will check, at least for my classes, that everything is in all the correct folders. So if something in my application is added, it will actually pick it up and say, hey, you didn't run the agent on this other OS. So let's do some more OS-specific shenanigans, shall we? Let's make this application a little bit bigger and make it a multi-module application. So what we're going to do is create an API. We're going to create a demo app, and we're going to use Unix and Windows. We're just going to use Unix for both OS X and Linux, because they do roughly the same thing, because they both use Bash. So with that, we have 4 modules now, and everything we just had in the application, it just moved into the app folder or the app module, and that's about it. So let's create a OS worker in the API. So we're just gonna create the interface in my API. And because we are working with modules, we need to create a module info in the API module as well. So we're just gonna call that demo.api. And then we're gonna create a OS worker impl in both Unix and in Windows. And for Windows, we're going to actually use the SunJNA platform stuff to actually write into the registry in order to set those environment variables. This is a very specific thing, and this also comes with some additional bindings that are only going to work on Windows. And this is also a module, and this module called demo.api.impl. So what we're going to do is add the demo API as dependency to our application. And we already had those nice profiles per operating system. And in that profile, we can also define which dependency is going to use. So for Mac, we're going to add the dependency OS X, and for Windows, we're going to use Windows, and for Linux, of course, also the Unix version. Then we're going to add those 2 modules to our application, otherwise this is not going to work. And that way we can just use the OS helper and say we want a new OS helper impl, and just work with that interface, and then we're going to be able to work with both Windows stuff and Linux stuff without having to have if statements on every single thing. So this is a very convenient way to handle multi-operating system stuff. So let's create a SDKMAN UI then. So let's fast forward a little bit in time. Let's add some stuff, your logo there, and some buttons and grids, and well, that's about it. So let's create the installer. We already seen that installer like before. It's just a dialog. If you click yes, it says SDKMAN is installed. Okay. What just happened? Well, 3 things happened. We copied some files into the home folder of the user, the SDKMAN/UI. There is also a third-party folder inside my application, because Linux usually has stuff installed like tar and zip and unzip. However, this is not the case on Windows. So we need to bundle those third-party libraries ourselves. So everywhere it works the same. So we copy ourselves to this UI location, and we're going to add it to the path. So how do we copy ourselves then? Because that's quite interesting. Well, you can actually get the location of the source code at runtime. And it's a bit weird, because if you do this at runtime in native, the source code is actually not the source code, but the thing that you're running in. So we can actually say that it's the location, and we're going to create a file, make it a file. And then we can actually say, is this a file? Because if you run it, for example, in just Java, it is not a file. It is the folder that you're running it in. So then it's not an executable, and then we cannot install it. But if it is a file, we can actually figure out where we are located and just copy that file to the to be installed directory. So that's quite a nice way to install our applications. Quite simple, but well, it works magics. So then we want to release our application. And for releasing, we're actually going to use JReleaser. And JReleaser is an application that handles everything that we are going to need. It is not specifically for Java. You can also use it for Go, Ruby, or C++ code. It doesn't really matter. It is written in Java, so that's quite nice. So if we're going to use this, we're going to add a jreleaser.yaml to our application. And in that jreleaser YAML, we can entirely configure how our release process is going to work. So first off, we're going to say that the releases are being pushed to GitHub. And on GitHub, we want to have a changelog, so we can actually see which changes are being done since the previous release. So that's quite nice. You can hide, for example, some contributors like GitHub itself, because if you release something, it will be committed by GitHub, and I don't want to have released version, the previous version, in my new version of the changelog. And then we're going to say we have a lot of distributions. In this case, we're going to have 4 distributions that we're going to have released. So how do we get those 4 distributions then? That has all been done with GitHub workflows. We have a assemble native workflow in there. And there we're going to use the matrix strategy to fan out on different services. So we're going to use Mac OS X 13, latest for Mac OS X, Windows, and Ubuntu. The reason why I'm using Mac OS 13, because that's the latest version of Mac OS that is natively x64. So the newest versions are the M1 chipset, so that's ARM-based. I think you can even build the x86 on that ARM machine, because it will use Rosetta as a virtual machine to handle it. Well, it should work, but I've chosen the safer option to use just the Mac OS 13. So if you look at this in our pipeline thing, we first do some pre-check. Then we're going to fan out over that matrix for target operating systems. And then we're going to release the early access thing even. However, in our pipeline, we need to handle those specific versions of the operating systems. So on Windows only, we need to add MS Build, for example, and install the Visual Studio shell, like before. But on Linux, we need to install some packages like Build Essentials, C++, and all that kind of stuff. And on OS X, we need to install Xcode. And this is all done with if your OS X, if your OS starts with a specific name, then only do that. And then we're going to set up the GraalVM for Gluon, like before. And then we're going to just build our application with native. Unfortunately, we are going to use a multi-module project. So first off, we're going to do a Maven install to install everything into our local Maven repository, because the GluonFX build is only available on our application, on our UI project. So we need to call that with Maven and then specifically say only build the SDKMAN UI project. That's why we're going to need the install first. And thus we're going to assemble a zip file, because the native application is around 80 megabytes large. And if you zip it, it's around 25 megabytes. So it's really nice for the users to not download an entire executable. And some virus scanners actually going to block if you download an executable from the internet. So zipping it really helps in the release process. And then we're going to just upload the package. And in the assemble stage, we're going to just download all the packages from the GitHub thing, and then it's being packaged up for JReleaser. And then we have, for example, a early access release, where you can actually download all the specific operating systems that you want. So JReleaser is a big topic on itself. There are some nice talks already on the internet. Thing by Tom Cools and Maarten Mulders last year for DevOps. And he did a talk, he created himself at JFall in 2021. So I highly recommend those two talks if you want to know more about JReleaser. And that's about it. You can download SDKMAN UI from my GitHub page. You can find me on Blue Sky, and these slides are entirely on SlideShare. So with that, I'd like to thank you.